This is Unit 10, Lesson 4. We're going to talk about correlation versus causation. So we'll first kind of define what the correlation coefficient is, and then we'll kind of talk about the difference between those correlations and causations. Okay, so correlation is a relationship between two variables. For example, height and weight, attendance versus grades, time versus distance. So anytime you compare two things, if there is a something that, like as one increases, the other increases, then we say that there is a correlation. The correlation coefficient, and the variable we use is r for that, is a number that shows how strong a correlation is and if it is positive or negative. So sometimes things are negatively correlated. Like as the number of days you miss school, then your grades go down. That would be a negative correlation. Okay, then causation is where one variable causes another variable to change. So just because things are correlated does not necessarily mean that there is a causation. Okay, so this kind of gives us the chart on reading correlation. So if you start here at the far left, 1, this is a perfect positive correlation because it forms a perfect line. 0.9, if you have a correlation coefficient of 0.9, then it has a high positive correlation. They look like they form a line, but they're not quite a line. 0.5 here. So you can still see there's some sort of correlation. It looks like they're, in general, increasing from left to right, but they're not necessarily close to a line. 0 would be no correlation, so your data points are just all over the place. Then the same goes with the negative, but this time they're decreasing from left to right. So a little bit of a negative correlation. Negative 0.9 would be high, negative 1 would be perfect. And then you could have values in between here too, like 0.75, 0.6. They would just be in between these numbers here. So 1 is a perfect positive correlation, 0 is none, and negative 1 is a perfect negative. So all your correlation coefficients will be between negative 1 and positive 1. Okay, so let's just here, I'm going to drag to match these correlation coefficients. So I'm going to start with the 0, because I think that one is the most obvious one. So it looks like right here. So if you want to pause this and take a minute to figure out which ones you think would match with which graph. Okay, so this looks like an exact line. This looks really close to a line. If I look at my negative ones, this is closer to negative 1, and this is closer to a line. And then here, which will leave 0.7 for here, for this graph right here. Okay, so fairly straightforward, nothing too hard with that. Okay, so this graph shows us temperature versus ice cream sales. And we can see as the temperature increases, and this is in Celsius, but it doesn't really matter. We can just look and see as the temperature increases, so does the amount of ice cream sales. So warmer weather and higher sales go together. The relationship is good, but it's not perfect because, you know, there's still some people that don't want to eat ice cream no matter what the weather, or maybe there was a rainy day. The correlation is 0.9575. You don't have to worry about calculating that yourself. But the warmer the weather, the more the ice cream sales are going to go up. Okay, this one. Sunglasses versus ice cream. So the number of sunglasses sold is increasing, as well as the ice cream sales. And so why do we think that is? Well, maybe because both of them increase in the summer. You know, the number of sunglasses because you're outside more, and then your ice cream sales go up because it's warmer out, and ice cream sounds better then. Okay, so the correlation between these is high, but does that mean that sunglasses make people want ice cream? Well, in general, no. What it means is that they are correlated. You can see that they almost form a line, but it is not a causation because the number of sunglasses sold does not make people buy ice cream. Okay, so here, temperature in ice cream, the temperature outside does make people want to buy ice cream. So that is a causation. But here, the sunglasses sold and the ice cream sales do have a correlation. You can see on the graph that they are both increasing at the same time. But it is not a causation. That does not make people want to buy ice cream. Okay, so we'll go through these and decide. So, would minutes exercising cause your calories burned to change? Yes, this is causation. Would eating more ice cream cause there to be more drowning? Well, no, but again, they both occur in the summer, so there probably is a correlation, but one does not cause the other. Grade on your homework versus grade in the class. So does the score you get in your homework affect your grade in the class? And now this one's debatable. You could probably argue it both ways, but I would say in general, because your homework counts for points, that it is going to affect your grade in the class. So I would say that is a causation. Height versus grades. Well, you can look at this one of two ways. So if you're talking about height, like everybody in 9th grade, then the height of the 9th grader is not going to affect the grade, and actually there's probably not even a correlation here. So we could say no correlation. But what if we were talking about grade, like not as in A, B, C, D, F, but talking about grade and like the grade you are in school, like your height versus 1st grade, 2nd grade, 3rd grade. Well then, yeah, I would think that there is a correlation. Now, it's not necessarily a causation. Your height would not affect the grade that you are in. It's your age, not your height, but there would be a correlation in that case. Okay, and that's basically it for this.